to talk about type 2, and then we'll also look at type 3 in the next video. So for type 2, I have a system of equation which looks something like this. I have r plus s equal to negative 12, and then I have the other equation which is 4r minus 6s equal to 12. So I'm going to call it equation 1 and this as equation 2. Okay. Now this is slightly different, and that's why I like to call it as type 2. This is slightly different than the previous one. Not too much different, but slightly different. So what is different about this equation is that none of these equations is actually solved for a particular variable, right? So if we are able to solve one of these equations in terms of the other variable, then basically we are transform this into type 1, and once we transform it into type 1, then we know how to solve a system of equations which looks like our type 1, the previous example. Okay, so looking at both these examples, it seems reasonable for us to actually work with equation 1 rather than equation 2. And one of the reasons for that is that in the equation 1, the coefficient for both my terms is just an invisible 1. So that is going to make our life easier if we are trying to solve for one of the variables. Okay, I mean, we can also use the other equation and solve for one of the variables, but it's going to be a little bit extra work. So in order to avoid that extra work and save some time, we should use equation 1. Okay, so guys, but keep in mind, there's not only just one way of solving or doing something in mathematics. There's always more than one ways. So when I try to use one method to solve things, at the same time, I want to let you know that that is not the only way. There's other ways of doing it as well. So if you want to explore other ways, go ahead and do it. And you should try exploring these things from many different ways, so that you can see that using this method or that method or the other method, you should finally be able to get the same solution. Okay. So for equation 1, again, it's up to you whether you want to solve for r or s. Let's say we'll solve for r here. If you like, you can also solve for s. So to get r by itself, you simply have to do one transformation, that is to get this positive s to the other side. And I'm not going to even actually write that extra step. It is basically accomplished by subtracting s from both sides. So if I subtract s from both sides, so it's going to look like r equals to the s will cross out on the left hand side. So it's negative s minus 12. So my equation 1 transforms into this if I just solve for r. Okay. So once I have this solved for r, then guys, that should take us back to type 1. Then we use this r, or we substitute this r into the second equation. Okay, so now I'm going to use the second equation, and wherever I have r, I'm going to replace that by this right hand side. So it's 4 times, so r will be, guys, don't forget to put this in parentheses because it is a binomial. So you got to put it in parentheses, and then there's a minus 6s. The rest stays the same. Nothing changes except for r. R is the only piece which is going to be replaced by negative s minus 12, which has been done here in blue, and everything else is the same. Now you just have to simplify and see if we can solve for s. So you got to distribute this. So it is negative 4s. Don't forget this negative. And this is negative, so that's going to make it 48 minus 6s equals to 12. Simplifying further, which in this case means combining like terms, so you can combine this with this. So that will add up to negative 10s minus 48 equals to 12. And how do we isolate s? To isolate s, you have to add 48 to both sides. So I'm quickly going to try to do that. I have negative 10s equals to 48 plus 12 is 60. And to get s by itself, got to divide by negative 10, divide this side by negative 10, 10's cross out here, negatives cross out as well, so I get s equals to negative 6. That is the value for s. So once we have the value for s, then we again use the idea of substitution to get the value for r. Again, from here, you can go back to equation 1, substitute the value for s and solve for r. Or you can also, if you want, you can also use equation 2 and substitute the value for s and solve for r. You can do that. Or what I'm going to do here is to save me some time. I already have an equation which is already solved for r. So if I use this equation, I'm going to save some time, right? So guys, when you are doing these type of mathematical problems, you got, like, I like to think of this as keep your eyes open and look at your work. Of course, it is easier to look at my work when it's like on a whiteboard and it's like big in bold letters, so it's easier to actually see that work. Once you are doing it, if you're doing it on a notebook, you may not be able to like have a look at that. I mean, you can look at it, but it's not that big and bold. So sometimes you may not be able to see each and every detail carefully. But we have to still keep our eyes open and look at all the equations and see which one we can use, and which one would be easier and convenient for us to actually get the other variable. Okay, guys, it does not matter. You can use number 1, you can use number 2, or you can also use this one, which is already solved for R. So I'm going to use this one for R. So if I use this one for R, my R is going to be negative S. So there's already a negative here, and then S, there is another negative. So I'm going to put that in parentheses. Guys, I want you to be careful with the negatives, because that's where I see sometimes students make mistakes when they have to deal with 2 negatives or more than 1 negatives at a time, and then there's a minus 12. So R equals to, the 2 negatives will become positive, minus 12, and when you simplify this is negative 6. So both R and S is negative 6, so that's like a coincidence here that both the values are the same, and we already know how to put them in. We like to put them as a coordinate pair. So R first, negative 6, and S, negative 6. So this is my R, this is my S. So we are actually done with solving the system, but let us also convince ourselves by verifying whether this solution actually satisfies both the equations. So to verify, let us start with equation 1. In equation 1, you have R plus S is negative 12, so negative 6 plus negative 6, and I'm going to put a question mark because we are verifying, so that's why there's a question mark, but we know negative 6 and negative 6 adds up to negative 12, so this satisfies. Left hand side equals to the left hand side equals to the right hand side. So equation 1 is satisfied, but we also have to verify this on equation 2 as well. So let's look at the equation 2. For equation 2, we have 4 times R, which is negative 6, minus 6 times S, which is still negative 6, and we are verifying whether that equals to positive 12, right? Let us simplify. So it is negative 24, you are multiplying 4 times this, 4 times negative 6, and then negative 6 times negative 6, so negative negative becomes positive, it is positive 36. Verifying whether that equals to 12. Well, negative 24 plus 36 is 12. 12 equals to 12. Again, left hand side equals to the right hand side. So negative 6 and negative 6 satisfies both the equations. So, and we are convinced that this is actually the solution for the particular system of equations. Okay. So guys, that is type 2. Now in the next video, I'm going to talk about type 3, and then we'll move on to using elimination as a method